A wilted tomato plant, yellow leaves curling around the edges. Soil so exhausted it falls apart like old ash between your fingers. $200 already spent on fertilizer this season, 3 separate trips to the garden center, and still the plants keep dying. But just 3 feet beneath that struggling patch of earth, a plastic bucket and a small handful of red worms can rebuild the whole garden for free in just 90 days. No tilling, no turning, a heavy compost heap, no painful weekend labor that breaks the back. Just a quiet underground laboratory doing the same work nature has done for millions of years, only faster and directly beneath the roots. This may be the strangest trash hack in modern gardening, and gardeners who try it almost never go back. Part 1. The invisible crisis under our feet. What if the real problem was never the plants? For years, the advice has sounded exactly the same. Water, more. Fertilize, more. Spray, more. And yet the tomatoes remain tiny. The peppers refuse to set fruit, and the green beans sit there sulking in soil that looks healthy but obviously is not. The truth is uncomfortable. Modern synthetic fertilizer works through one simple exchange. Feed the plant today, weaken the soil tomorrow. Those blue crystals and white granules force quick green growth within weeks. But the tiny living creatures that normally recycle nutrients underground, the bacteria, the fungi, the earthworms, begin to go silent without them. Each new season starts weaker than the one before, and the season after that becomes weaker still. Slowly, the garden forgets how to feed itself. And this is not a small issue. The United Nations Food and Agriculture Organization has warned that around 1/3 of the world's soils are already moderately or severely degraded. When soil loses its living community, it also loses the power to hold water, hold nutrients, and grow real food. It stops being soil and becomes dirt. So why does almost nobody say this out loud? Because healthy soil is difficult to sell. But a bag of blue crystals that makes a plant turn green in 48 hours is very easy to sell. The logic is economic, not necessarily evil. But the result is still the same. Gardens everywhere are quietly being fed to death. And here is one thought that makes many lifelong gardeners uncomfortable. The best garden is not the one with the most fertilizer, the most mulch, or the most expensive tools. The best garden is the one that needs the least help from outside. That is a quiet kind of success, and it is almost the complete opposite of what every gardening commercial teaches. The solution is not in a bottle. It is not waiting on a shelf inside the garden center. It is already sitting on the kitchen counter, inside the coffee filter, inside the eggshell, inside the peel of last night's banana. Part 2. The quiet wisdom of retro gardening. Before synthetic fertilizer ever existed, how did gardens feed families through the winter? The answer was found in every kitchen. Grandparents did not have a garden center to drive to. They had coffee grounds, crushed eggshells, scraps from last night's dinner, wood stove ashes, and the rinse water from vegetables. And somehow they grew tomatoes that would embarrass anything sitting today under supermarket fluorescent lights. Take the simple eggshell. When it is rinsed, dried and crushed into a coarse powder, it delivers calcium carbonate, the same mineral that helps prevent blossom end rot, that ugly dark patch that ruins so many tomatoes and peppers. But here is the first mistake many people make. Whole half shells thrown into a garden bed can take years to break down. But when they are crushed fine, almost like cornmeal, they begin releasing calcium over a few months. A simple coffee grinder, kept only for garden use, can do the job in seconds. Then come the used coffee grounds. And this is where almost every gardening article online gets the story wrong. Used coffee grounds are not strongly acidic. The brewing process pulls most of that acid into the cup. What remains in the filter is close to neutral, usually around pH 6.5 to 6.8, which is already very close to the ideal pH for a vegetable garden. The real value of coffee grounds is something else. They feed soil microbes. They add slow-release nitrogen, and they improve soil texture. But they do not meaningfully lower soil pH, no matter how many times the Internet repeats that myth. The horticulturalist Alan Titchmarsh has used these frugal garden tricks for more than 50 years. Banana peels, wood ash, nettle, water, comfrey leaves, all of it. The Royal Horticultural Society in Britain has documented these kitchen garden methods for generations. None of this is new. Most of it is older than the compost bin itself. But when these scraps are only scattered on the surface of the soil, they can only do so much. Rain washes them away, ants carry them off, and the sun dries them out. Before the microbes ever get their chance, the real transformation, the kind that can turn a failing garden into a living system, only begins when someone decides to bury them. Part 3. The Crazy Trash Hack Revealed. A Backyard Alchemy Lab. What happens when the compost pile is moved from the far corner of the yard to directly underneath the tomato plants? Everything changes. Most gardeners have tried a traditional compost bin at least once, and the problems become obvious very quickly. It sits in a sunny corner. It smells during summer. It has to be turned with a pitchfork every few weeks, which becomes almost impossible for anyone over 65 with a bad shoulder or worn knees. And by the time the compost is finally ready, 6 months later, it still has to be carried in heavy buckets across the yard and spread by hand. But there is a much quieter method. It has been used in experimental permaculture gardens for decades, and in some scientific circles, it is called a subsurface bioreactor, which is a complicated name for an incredibly simple idea. A backyard alchemy lab buried exactly where the plants are growing. The method takes about 10 minutes and costs almost nothing. Start with a food-grade plastic bucket, the 5-gallon kind that bakeries and delis will often give away for free. Drill holes at least half an inch wide all around the sides and across the bottom. And here is the second common mistake almost nobody warns beginners about. Quarter-inch holes are too small. Worms cannot easily move through them, and roots do not have enough room to enter. Half an inch is the minimum. Larger is even better. Dig a hole in the middle of the garden bed, deep enough so that only the top 4 inches of the bucket and the lid remain above the soil. Place the bucket inside, backfill the soil around it, and that is all. The bucket has now become a permanent feeding station for every plant within a 3-foot radius. Each evening, kitchen scraps go straight inside. Banana peels, used coffee grounds, crushed eggshells, tea bags, carrot tops, apple cores, wilted lettuce. Close the lid and walk away. No turning, no smell, because the lid stays shut and the food remains underground. No pests, because raccoons and rats cannot reach what is sealed and buried. For gardeners who care more about beauty than pure practicality, an unglazed terracotta pot can work even better than plastic. Terracotta is naturally porous. Liquid nutrients, often called leachate or compost tea, slowly seep through the clay walls into the surrounding soil. A quiet drip feed that can last for weeks. From a single filling, 2 stacked terracotta pots, one turned upside down as a lid, become a miniature alchemy tower that can remain in the garden for a decade. Here is a small, uncomfortable truth that deserves to be said. Most bagged compost sold at the garden centre has been sterilized. High-temperature treatment kills weed seeds, yes, but it also kills most of the living microbes that make real compost work. A buried bucket fed every day with fresh scraps creates something a sealed plastic bag never can. It creates living compost. But the bucket itself is only the structure. What actually eats the scraps? And this is where nearly every new convert makes the biggest mistake of all. This is where the story becomes strange. Part 4. Why most garden worms die in a compost bin. Why do so many people who try this exact method fail on the very first attempt? Because they put the wrong worm inside the bucket. Walk into almost any bait shop and ask for worms. The tub on the counter will usually be full of big, fat nightcrawlers, scientifically known as Lumbricus terrestris, the worm most people imagine the second they hear the word worm. Drop a dozen of them into a compost bucket. Pay $12 for the privilege, and within a week most of them will be dead. The reason is biology, not bad luck. Nightcrawlers are deep burrowing worms. In nature, they live in permanent vertical tunnels that may reach 6 feet down into undisturbed soil. They feed on soil and dead leaves from the surface, pulling them down at night. They are not designed to eat fresh kitchen scraps. Place them in a shallow, food-rich compost environment and they panic, overheat, and die within days. The worm that truly belongs in the bucket is smaller, redder, and almost never found in a typical American bait shop. Its name is Eisenia foetida, but most gardeners know it by a friendlier name, the red wiggler. Red wigglers are what biologists call epigeic, which is just a fancy way of saying surface dwellers. In the wild, they live in rotting leaf litter, forest floors, and old manure piles. Exactly the kind of environment that forms inside a buried compost bucket. They thrive there. They can eat close to half their body weight in waste every day. A single pound of red wigglers can process a pound of kitchen scraps in 2 to 3 days. And what they leave behind has carried a nickname among serious gardeners for more than a century. Black gold worm castings are nothing like raw compost. They are concentrated, water-soluble packets of nitrogen, phosphorus, potassium, and a living cocktail of beneficial microbes, perfectly balanced and already in a form that roots can absorb quickly. The results sound unbelievable until they are seen. A 2019 meta-analysis of dozens of independent vermicompost trials found average yield increases of around 26%, biomass gains of 13%, and a remarkable 57% increase in root mass. Cornell University vermicompost research has documented some vegetables showing yield gains of up to 50% when worm castings replace synthetic fertilizer. A pound of red wigglers costs around $30 online, and that is a one-time purchase. Within one season, they begin doubling their population within a year. The garden has its own self-renewing workforce, one that never takes a day off, never asks to be paid, and quietly turns what used to be garbage into something more valuable than most products on the garden centre shelf. But the red wigglers are not working alone beneath the soil. Something much smaller, much stranger, and much more powerful is doing even heavier work. And almost nobody in the gardening aisle ever talks about it. Part 5. The Invisible Architects. What actually creates that crumbly chocolate cake soil that every serious gardener spends years trying to build? The answer is probably not what most gardeners would guess. It is not the worms. It is not even the compost itself. It is something invisible to the eye, deep inside the buried bucket. A microscopic transformation begins. Bacteria arrive first, fast, hungry, and ready to break down the soft sugars in banana peels and apple cores. They work quickly, releasing heat and simple nutrients. A fresh bucket can warm to over 100 degrees Fahrenheit in the first days from microbial activity alone. Then the fungi arrive. Fungi handle the harder jobs: the woody stems, the cardboard, the coffee filters, the fibrous materials that bacteria struggle to break down. One group of fungi in particular, called trichoderma, does something remarkable. It breaks down tough material while also suppressing soil-borne pathogens, the ones that cause root rot, damping off disease, and stem canker. A free, round-the-clock bodyguard for every plant in the bed. Nearby live the mycorrhizal fungi, the most important garden partner. Most home gardeners have never heard of these fungi. Connect directly with plant roots in a true symbiotic relationship. They send out thread-like strands called hyphae deep into the compost bucket to mine nutrients and deliver them back straight to the plant. In exchange, the plant gives them a little sugar. A tomato plant connected to healthy mycorrhizae effectively has a root system 50 times larger than what can be seen. 50 times, that is the difference between a plant that wilts during the first hot afternoon and a plant that stays firm through a full week of drought. And then there is glomalin. This is the detail that almost never finds its way into gardening books. Glomalin is a sticky, glue-like protein made only by mycorrhizal fungi. As they grow, it coats soil particles and binds sand, silt and clay into small, stable crumbs, that rich, crumbly chocolate cake texture every gardener wants. That is glomalin, and it only forms where fungi are alive and actively working. No fungi, no glomalin, no crumb structure. Which is exactly why chemically sterilized soil stays hard and cracked no matter how much fertilizer gets poured into it. This is where a lot of old-school gardening wisdom starts to look questionable. Every spring, millions of gardeners turn over their beds with a shovel, a fork, or a rototiller. It feels productive, it looks clean, but it also shreds the fungal network that took all of last year to build. Every spring tilling session is, in a very real sense, tearing down the invisible infrastructure the garden needs to feed itself. A buried bucket system does the opposite. It never disturbs the fungi. The scraps enter from the top, while the network underneath stays intact. The final product of all this quiet work is humus, the dark, spongy, sweet-smelling material that can hold up to 90% of its own weight in water. A single 5% increase in organic matter can quadruple a garden's ability to store water during a summer drought. For the gardener with a sore back and a heavy hose, this is the real quiet miracle of the entire system. Less watering, fewer emergency rescues during heat waves, and more forgiving soil season after season. And for those who want to push the system even further, the entire living community inside that bucket can be concentrated into a liquid and sprayed directly onto the leaves of a dying plant. Part 6. Brewing the elixir. Aerated compost tea. What if the soil's entire living community could be brewed like tea and sprayed onto struggling plants? That is exactly what aerated compost tea does. Think of it as taking the best parts of the buried bucket, the bacteria, the fungi, the microscopic protozoa, and multiplying them 1,000 times over inside a bucket of water. The result is a golden, earthy-smelling liquid, and when it is sprayed onto a weakened plant, it coats the leaves in a living armor of beneficial microbes. Dr. Linda Chalker-Scott, an extension specialist at Washington State University, has warned that compost tea is not a miracle cure. There is no silver bullet in gardening. But she has also documented that under the right conditions, compost tea can suppress certain plant diseases and give weakened plants a meaningful boost. The brewing process is simple, but every step matters. Start with 5 gallons of clean water in a food-grade bucket. And here is a mistake almost every beginner makes. Municipal tap water contains chlorine, and chlorine kills the exact microbes the tea is supposed to multiply. There are 2 easy solutions. Leave the water sitting in an open bucket for 24 hours, and the chlorine will evaporate on its own, or crush 1 vitamin C tablet into the water. The ascorbic acid neutralizes chlorine in about 15 minutes. Add 2 cups of high-quality worm castings. Tie them inside an old pillowcase, cheesecloth, or a mesh paint strainer bag to feed the microbes during the brewing cycle. Add 2 tablespoons of unsulfured blackstrap molasses. Molasses feeds the bacteria for the fungi. Add a spoonful of liquid kelp or fish hydrolysate. The amino acids and complex carbohydrates cause fungal populations to explode. The final essential piece is a simple aquarium air pump with an air stone. The pump pushes oxygen steadily into the brew, which allows aerobic microbes, the good ones, to multiply rapidly. Skip the pump, and that same brew can turn into a foul, rotten, anaerobic sludge within hours. The smell tells the whole story. Sweet and earthy means the brew is alive and ready. Sour, rotten or ammonia-like means dump it and begin again. After 24 to 36 hours of steady bubbling, the tea is ready. But it has a very short shelf life, 4 to 6 hours. Once the pump is turned off because the microbes begin starving for oxygen, spray it on the leaves at dusk when the sun will not burn the living microbes. By morning, the plant is covered with a protective shield of beneficial organisms, outcompeting disease for space. And once a garden receives this kind of daily and weekly quiet support, something unexpected starts to happen. Part 7. When the garden stops needing the gardener. How can someone tell when the system has truly taken hold? After a few months, the soil begins to change in a way that is difficult to explain until it is felt underfoot. It becomes darker, it becomes softer, it smells faintly sweet, like a forest floor after autumn rain. The worms multiply on their own. The fungal networks spread quietly through the bed. The plants begin drinking less water while producing more fruit. And, strangely, the weeds seem to struggle more than the vegetables. Some gardeners add one final layer at this stage, a product called effective microorganisms, often shortened to EM. Developed by Japanese professor Teruo Higa in the 1980s, EM is a carefully blended mixture of beneficial bacteria, yeasts and fungi, designed to speed up the shift from dead dirt to living soil. It is completely optional, but for a garden that has been abused by years of synthetic chemicals, EM can reduce recovery time by roughly half after a full growing season. The strangest and quietest realization starts to settle in. There is almost nothing left to buy. No fertilizer, no bagged compost, no synthetic pesticide. The kitchen trash has replaced every expensive product on the garden center shelf, and the garden itself has quietly become the product. Neighbors begin to notice. They ask what the secret is, and the answer disappoints them almost every time, because they expected a product name. They wanted a shortcut. But what they get instead is a buried bucket, a handful of worms, and a little patience. The bucket, buried and forgotten, keeps working year after year. Conclusion. Look at the garden now. The yellow leaves are gone. In their place, deep green tomato vines climb their stakes heavy with ripening fruit. The beans produce so much that neighbors start finding bags left at their doors. The soil, once grey and tired, is now dark, alive and fragrant in the palm of a hand. All of it came from a buried bucket, a handful of red worms, and a kitchen that used to send its scraps out in a trash bag every Tuesday morning. This is the part worth sitting with for a quiet moment. The Japanese farmer and philosopher Masanobu Fukuoka once wrote that the ultimate goal of farming is not the growing of crops, but the cultivation and perfection of human beings. A garden like this cultivates patience. It rewards quiet observation. It gives back in food and beauty. Whatever care is given to it, anyone watching can begin this week. 1 bucket, 1 drill, a half-inch bit, a handful of red wigglers, 90 days of waiting and watching. And when the first real tomato of the season arrives, the size of a softball, there is only one question left worth asking. What else in this life has been thrown away that was always worth more than anyone realized? Thank you for spending this time in the garden. Keep growing, keep wondering, and always remember to nurture your roots.